Welcome everybody to our February session of the Ask Tom Spatial series. Today I've brought a couple of topics I've worked on over the past weeks, and I thought it might be good and worth to share some of the insights or some of the tips and tricks I've seen and I've learned over the weeks. And while using those tools, I will be talking about today. Okay, my name is Karin Patenga. I'm part of the Oracle database product management team. Our sub-team is responsible for spatial and graph technologies. And today, of course, since it's the spatial series in the Ask Tom office hours, we will be talking about spatial, of course. Let me go ahead. Just in case you are new to this series webinars, we have done quite a lot of sessions in the past. You can find all the recordings using either the QR code or searching for Ask Tom, and then filtering the recordings which you can find here underneath videos for spatial series, and then you will see all the published webinars we've done so far. You can also use or directly search on YouTube. All the webinars, recorded webinars, are published there as well. If you want to have specific topics covered in one of the next sessions, or if you are volunteering to present your own project during one of our Ask Tom sessions, feel free to reach out to us. So here are two email addresses for another colleague in my team and myself. We are happy to receive your notes and ideas about topics we should be talking about or you want to talk about. The scripts I'm going to use today and also the data used for the demo part, you will be finding in my GitHub repo. And I've shared the scripts and data for previous sessions in the same GitHub repo. Just search for the folder 2025 and 02 is for February. And there you can find the respective scripts and data sets. And I'm going to show you later or use the scripts later so you can have a look at them right away. Okay, what do we have at the agenda for today? I originally announced 4 topics. When preparing the topics, I realized that 4 topics won't fit into 1 hour. So the last topic, I'm going to give a heads up, but this will be left for one of the next sessions. But before when we have that session, I'm going to publish a blog post about what I wanted to share with you. And it might be a good option to have that blog post ahead of a presentation so you can follow better what we need in terms of the tool set you need to set up prior to setting up web map tile services using the Oracle Map View or Map Visualization components. So that's what I'm going to postpone right now. But the other 3 topics, those are the ones we will be talking about, and I've also prepared demo parts for those. So the first thing is that we will be looking into new features or additional features with regard to in-database routing and computation of drive time polygons. The second topic is about the Data Studio feature of the autonomous database, and there we have an enhancement for the load of GeoJSON files. So this is an additional option now provided directly by the autonomous database rather than using Spatial Studio. But of course, you have both options to work with. And I'm going to present how you can use Data Studio to load GeoJSON files. And the third topic is about loading openly available data sets provided as so-called web feature service. Now we'll be talking about a little bit about web feature service in general and how you can use the web feature services in order to retrieve data about features or featured data sets and use those directly in Spatial Studio. So let's jump into the first topic, in database routing and more. So as already said, that we want to look at the extension of the geocoding and routing functions inside the Oracle database, and specifically here inside the autonomous database, since we will be talking about the functions that are specifically available for the autonomous database. For the intro, we are talking about the PL SQL package SDO_GCDR. GCDR stands for Geocoder. This is a package owned by the MDSys database user, and it contains all subprograms for performing in-database geocoding and routing. And the functions that have the prefix ELOC, those can be used by autonomous database users to do in-database routing and computations of drive-time polygons and isopolygons. The ELOC functions, as well as all the other functions inside that SDO geocoder package, reach out to the Oracle Maps Cloud Service, a fully managed Oracle Cloud Service that provides reference data sets for geocoding and for routing. And the content provider we use for those data sets is here. There are no additional costs for ADB users to those use the reference data sets, and of course the service as well. And those are the indirect things, and the direct thing is that there are no additional costs related to using the SDO_geocoder package. In order to be able to use that package to execute the functions, you need to have specific permissions, or the database user using the functions need to have permissions granted. And I'm going to show you how you can set those permissions. And these permissions are required to set underneath the access control list that the networks are attached so that the database can talk to the Oracle Maps Cloud Service. Which are the functions we will be looking at? So everything that starts with ELOC, and here specifically those for computation of drive-time polygons, the isopolygons, and everything that is related to ELOC_route. And for documentation purposes, you can find here the link to jump directly to the documentation to figure out what the signatures for those functions are, and explanations about the parameters used. I'm going to explain a little bit about the parameters, but you don't need to keep everything in mind. That's what you have the documentation for. Once we have done the demo part, we will be seeing that we have drive-time polygons calculated. And this is an example of drive-time polygons which are either based or related to different locations in Germany and Hamburg and the place where I live around that one. And on the right side, you can see polygons related to the same starting location, but with different parameters. So you can see drive-time polygons. So the area you can reach within 1 hour, 2 hours, and 3 hours. So this is what we are going to see right now. And let me go back to my presentation. And I'm not sure whether somebody from the team has joined the conference. Yeah, Hans and Denise. Is there a question in the chat or in the Q&A session I need to cover first?
Yeah, we got a question. What if using database as a service?
The function I'm talking about is not available for DBCS. It's only available for autonomous database right now. Does that answer the question?
If we get a follow-up, I'll let you know. Thanks for pausing.
So let me go to, okay, maybe I start with that part here, just to give you the idea where to go to find all the scripts and data sets. So here are the data sets we will be looking into later on, and the scripts you find here. And I've included the scripts for the 3 parts we'll be talking about. And let's start with the ADB routing and calculation of drive-time polygons. And this is what I'm going to show you right now using my script. For that purpose, I've open Visual Studio, and I have connected to my autonomous database instance. This one is an Ashburn, and let me attach that connection to my script. I'm not sure how long it does take. Let me use the time to explain how you can grant the permissions to the users that should be able to use the elog functions. And this is something you need to do as user admin in your autonomous database. So you simply execute sdo underscore geocoder elog underscore grant underscore access. And the parameter you provide here is the username. Of course, if the permission is no longer needed, then you can revoke the permission using the elog revoke access for the same user. Once you have done this, I can log in as user ask Tom user, which I've done here, and then we can go ahead and see what the signature of those functions is. And let me start with this elog drive time polygon. We have here an overloaded function that can either work with single line addresses like this one, and this is complemented by the country parameter. Or what you can also do is to work directly with longitude and latitude values. So instead of the single line address and the country code, you just use longitude and latitude. What other parameters do you have? The first parameter defines your routing preference. It could be fastest, shortest, or others. This is described in the documentation. Right now, traffic defaults to fastest. I'm pretty sure there will be future enhancement that also take into consideration the traffic. But for right now, shortest and fastest are the ones we support. And if you choose traffic, then, as I said, it defaults to fastest. What else do we have? We have a so-called cost parameter, which is dependent on the cost unit. So if I define minute, which also is related to the type of my routing preference, so minute is related to fastest, or kilometer and meter is related to the distance. So here we say that the cost is 8 minutes. So we want to have the drive time polygon that is 8 minutes around my given location. So which places do I reach within 8 minutes from that place? We also can define the type of vehicle. Right now we have either auto or truck supported. And let me run that part here. What you can see is it returns an SDO geometry object that is a polygon, which you can see here on the first parameter for that coordinate system. And here we have the rest of the definition and the actual vertices of that polygon. This is what you get as result. And the same applies for having the polygon computed for longitude and latitude. It's the same result, or kind of same result as before for the single line address. Let me just do some calculation with it. So I'm going to create a table that has either addresses or longitude and latitude values. And I've also defined the routing preference, cost type, cost unit, vehicle type, and I want to have the drive time polygon stored in that table. So let me create this one. And now I'm going to insert a couple of addresses and also the routing preferences, just for to have an example for that. So here are the locations in Canada I talked about before, and the last one is this one. Now let me just commit that one. And what you can see here now is that I have a table containing either single line addresses or longitude and latitude values. And I've also provided the different parameters here. What you can see next, and what I'm going to do next, is I've just written a tiny PSQL function procedure that uses all the values from that table and computes the drive time polygons, and then stores the drive time polygons in the same table. So what you find here is actually everything that has drive time polygon is still null. We can fill up with the respective drive time polygon. And for that, I've made, of course, the distinction of whether we are using either the address or longitude and latitude. And once I've done this, let me execute the function. You can see down here that the procedure was executed, and then we will be seeing that we have fully the SDO geometry objects here at the end, exactly the drive time polygons as SDO geometry objects. And that's exactly what I imported into, I imported the table as a data set in Spatial Studio. And in Spatial Studio, I can then display the geometries. In order to do that properly, I of course need to create the spatial index as well. Okay, any questions so far regarding how to use elog drive time polygon? Can somebody give me a hint? No questions? Okay.
No questions, Zark.
Okay, perfect. Then let me go ahead. The same, what I've said before, also applies for elog_iso_ polygons. So we calculate the iso polygons given either a location as a single line address, or later you will see it also for longitude and latitude. And here we have, again, the cost unit, both related, the cost unit and cost to the type, whether it is time-based or distance-based. So the same as before, like fastest and shortest. And what you can see now, oops, I'm sorry, that wasn't what I wanted to do. So here we go. And now this elog_iso_polygon function returns a JSON document in order to have a better idea of what's inside the JSON document. We can also use JSON value to extract the different parts of that JSON document. So for doing that, you can see here that we have the cost type a 10 or cost 10 and cost unit is minute. And here we have the geometry as a JSON object. And the same, of course, applies for, here we have time-based with a single line address, and here we have time-based with longitude and latitude. So it works the same way. Now we have, instead of time-based, we have distance-based queries using kilometer, or we could have used miles or other units as well. So here we get the result of it. And again, using JSON value to extract the different values of that JSON document. So this is actually what you can do. And here, let me just briefly do that. An example for elog_route. So calculating the route between two locations. And that's why we have here two pairs of longitude and latitude, one for the start location and one for the destination location. And then we can calculate the actual route. And again, using our JSON support inside the Oracle database, which JSON value, we can extract the different parts of that result set and return it separately. Okay, so here again, time-based, and with longitude and latitude, and here we have time-based with two actual single line addresses, which is pretty good because that's almost from home to the mid of Berlin, and this is realistic time and distance on a Saturday morning, I would say.
That actually touches on an interesting point which came up as a question in the Q&A just a moment ago. Because of this service being a bit sort of opaque in that you send a request somewhere and you get a response back, the question was, does that take into account traffic or real-time traffic? And as you just said, this is probably a good estimate for Saturday, but not something during rush hour. That indicates, yes, it is not real-time traffic based. So we're not offering a real-time traffic based API.
That's true. Right now, it's not real-time traffic-based as far as my understanding is, but since we have prepared it already with that routing preference traffic, I assume that there will be enhancement with regard to realistic traffic profiles in the future. Does that answer the question?
Yeah, absolutely. Yeah, thank you.
Okay.
That was great.
So let me finish that part. As I said, the script you can find in the GitHub repo, so you can try it out yourself or modify it how you like it and then run it. Good. Let me put that away for a second and let me get back to this one. Loading GeoJSON using Data Studio. So far, we have seen in several presentations, webinars, documentation that we are completely fine using Spatial Studio to load GeoJSON data into an Oracle database, and this does not have to do with whether it's an autonomous database or database cloud service or an on-prem. You can use Spatial Studio for all these different environments. Loading GeoJSON with Data Studio, of course, is a feature of the autonomous database because Data Studio is one of the tools for the autonomous database. So it's an additional option you can use, and I'm going to show you how you can use it based on freely available vector data sets. Here, the admin boundaries, and I've chosen one of a country of Morocco in this case. I've also picked vector data set provided by Natural Earth, and here are the links where you can find the data sets. In order to use Data Studio, the database user needs to have a DW role, which can be assigned by the admin user again. So grant DW role to Ask Tom user. This is what I've done in advance to be able to use Data Studio with that user Ask Tom user. Two more things you need to know in advance. GeoJSON makes use of the coordinate reference system WGS84, or what you know with the SRID 4326. So make sure that your data set has this reference system. And once you have imported the data, you also need to make sure that the spatial metadata and the spatial index are created. So with, you've seen in one of my previous casts that with 23AI, once you create the spatial index, the spatial metadata are automatically registered. So if you have 23AI, you can just use that way to create the index and have the metadata registered. The documentation you can find here. So if you want to check in more details, just feel free to open that link. And what we will be seeing at the end is these two data sets I've again visualized using Spatial Studio. And this is now my time to go back to browser. Okay, and here we go. Here is my autonomous database, in this case 23i, database actions. You see here I've connected as Ask Tom user to the database, and here we have Data Studio. And let me just open data load. Might be familiar, and I'm just going to grab two of the several data files I've uploaded into the GitHub repo. Here, the first one is a JSON document or document with the file extension JSON. And you have two options to load JSON documents into the autonomous database. And I want to load it as a table in my case. And the other one has GeoJSON. This is automatically assigns extracting the data and putting those into a table. Here we have the two data sets, and we can check the settings for it. So here we have the populated places, and for time being, since with Data Studio not yet supporting Boolean, just to make sure that there is no unexpected behavior, I'm going to remove those columns from the import. The Morocco data set are admin boundaries of level 1, and I think I have forgotten to remove the existing tables. Okay, it doesn't matter. This is what I'm going to start now. Running the import, and you see here that I, of course, have done the test before, but I missed to drop the tables. So we are now creating second version of those tables. Doesn't matter. Okay, once this is done, we can actually look into our database. And let me open another connection. So this is where the data have been imported to. Let me check. Okay, once you load data using Data Studio, you find those tables copy bad log, which you can check and later on drop those. And here you can see that I forgot to remove the previously imported data sets. So it created new tables for the same data. Okay, and what I always recommend is once you have loaded new data, you should make sure that the data are valid. Let me just go briefly through that one. So checking what type of data we have. Okay, I need to to assign connection to it. So this is the one. Just wait a second to have the connection attached. Okay, here we go. And now we can see that in this these admin boundaries of Morocco are of type multi-polygon and polygon, and the natural Earth data set, those are points. And this you might have seen before is about validating the newly imported data. And here is a script to do that, which you can find in several places. So here I have the script checking all the geometries in those tables and figuring out which of those are not valid. And the procedure was executed, and then we get some results of it. And what you can see here is that this error code table is empty, which means that all the imported geometries have passed the validation in relation to the chosen tolerance. And once this is fine, you can actually go ahead without taking care of rectifying or correcting your geometries, which would be this procedure. Okay, so let me go back to my Spatial Studio instance. Spatial Studio and Spatial Studio, I have the connections to my different database instances. Then I have previously imported the different data sets. So here we have Morocco, here we have natural Earth populate places, and here are the drive time polygons. And let me go back to my project, which I've created before. And here we can see the populated places. Okay. Then we can see the admin boundaries of layer 2. Any questions with regard to how you can load GeoJSON documents into an autonomous database using Data Studio?
There are no questions in the Q&A.
Okay, perfect. Then let me go ahead and let me show you another way to load spatial data into an Oracle database, again using Spatial Studio. And this time we want to use the web feature services, which expose vector data in many places, especially in open data portals across the world. And making use of those data, you can access the WFS endpoints and get the data directly from there. And this is what I want to show you right now. So the web feature service takes care of geometries or features, feature types. So there are different terms that are equally used, and it works with vector data. And what we want to do right now is using this web feature service or web feature services to get access to existing data and use those data in our database. The description of web feature service in general and all the different operations you can find via this link. And let me just briefly go back to my browser. And here you see that we have data access standards that are related to vector data such as web feature service, but you can also find spatial web services related to other types of data like raster data, which is what this web coverage service is for, or we have visualization standards like web map service and web map tile service. I previously I wanted to talk about today as well, but what I'm going to publish in a blog post. So right now we want to have access to data that are features, and for that we use the web feature service, and we will be using two types of requests. The first one is get capabilities. The get capability request tells us what we can get, and the get feature service tells us how you can provides us the actual data. And let me just go back to my GitHub repo, and there I've prepared a few links which are in this third document, WFS requests. And what you can see now is that I'm going to use the get capability request, figure out what kind of data I can get and what kind of parameters do I need to specify in order to get the data I'm looking for. The web feature service has different versions of standard, and here I'm going to use an example that is related to the standard version 2.0. We also have an example for a web feature service of version 1.1. Let me start with that one. And what you can see here now is an XML document that defines what you can get via this web feature service. And it talks about, I think I should first go to the next page. So The request, the get capabilities request, you can see also here. So this is the one for Web Feature Service version 2, which you can find here as a parameter inside this URL. So you have a set of key value pairs as parameters after the question mark. The service is WFS. The version of the service is 2.0.0, and the actual request is get capabilities. This is what you have seen before. And then you see it returns an XML document which defines a lot of other, or which provides a lot of other information. And those information are used in the actual get feature request. And what I've done is I've extracted the information I'm looking for from that XML document, especially with regard to which features are provided directly as GeoJSON. Typically, that feature request returns data as GML, but you can specify the output format to directly get GeoJSON. And this is what I've done here. I've defined the output format JSON. Then I've looked at the feature types that are available, and I've picked this one, which is actually a layer in the data or a vector data set provided. So this is the one I've chosen. Then I've also made sure that the coordinate system supported is 4326, so WGS 84. And this is my actual request. Similarly, it applies for the second service based on the XML response I'm getting from that get capabilities request to this Canadian service. I defined the different parameters like type name, which is here managed forest tenor, and a second type. So 2 layers put together. The output format again is GeoJSON, and the coordinate system is again 4326. And let me go back to this one. So this is the second get capabilities request, and let's try to figure out where you can find the information inside the document. So here, for example, you can find which versions are supported by that WFS, and then later on you can see further down related to layers also which output formats are supported. And here you can see that JSON is supported, and then underneath feature type you copy and paste those names of the features you want to retrieve from the service into the URL in order to get the data. We have the version specified, we have the feature types specified, and here you can find as well which coordinate systems are supported, and this is the one we are looking for, and we need to specify it as well in the URL to retrieve the data. So that's basically everything I've done. Here's a second feature type. I've used my second request, and this is what we will be seeing now. So once I didn't want to do that directly, I just wanted to open it in a different window. So here we go. And this is the result set of the first request to that German web feature service, and then to the Canadian one is this result set. And of course, we could now store the result set and then load the GeoJSON into the database, but I find it much more elegant to directly use Spatial Studio to load the data sets. And that's what we are going to do right now. So let me create a new data set. What you do now is, instead of database, table view, or something else, Locify, we insert the URL for that. So let me go back and take this one, grab that URL, and use it directly in. Oops. Sorry. Okay. Oh, I forgot one thing. Sorry. Let me just go back 1 second. In order to do that, you need to register the domains of the service as so-called safe domains. And here we see that I've already registered the SGX Geodatenzentrum for Germany, and as well the domain for the Canadian web feature service as so-called safe domain. So this is something you need to do in advance. And once you have done this, then we can go and load the data set or create the data set. Okay. Let's give it a name, this. Okay. And here we go. We have a new data set, which we can now use in our Spatial Studio project. You see already that it's recognized as a spatial data set. The only thing that we see that it complains about is the missing key, but for our purpose of just displaying it, it doesn't matter. So we want to have that web feature service added, and now we fully see the web feature service. And here we go, zoom to layer. And these are administrative boundaries in Germany for so-called Regierungsbezirke. Okay, you're able to directly attach or get connected to a web feature service and use the data that are returned by that feature service in your autonomous database by loading the data via the URL into Spatial Studio and have it registered as a data set which you can use in your projects. Okay, let me just go back and see what else we have. So here you see the example, having the forest map of Canada imported and displayed in Spatial Studio. This is what you can see. Okay, so you've seen different approaches to work with spatial data, accessing spatial data that are publicly available, using them in your projects by either importing them directly into your autonomous database or by accessing the web feature services using Spatial Studio and having the data set registered in Spatial Studio and using those Spatial Studio projects. What we will be doing another time is, what I had also started to prepare for today and will be finishing it as a blog post, is the way of accessing raster data information you have stored in your Oracle database as so-called webmap tile services, using the tile services in your applications. That's what I wanted to show you today. And if there are any more questions, I'm happy to take those right now.
There's a question on web feature services that only deliver XML rather than JSON. Does what you've shown also work with XML data?
No, that's not working the same way. What you always can do is storing the XML documents in your database and then using the XML support inside the Oracle database to extract the relevant information. And I think we have somebody in our audience who has done this extensively, and maybe he's volunteering to show that in another session. I don't want to call out somebody.
Yes, let's not put them onto the spot. No, that's right. Good. Okay. Or alternatively, maybe you can actually also save the raw GML data file and then ingest it using GDAL or something. So I think also that
there
might
are
be an option.
plenty of options.
There's lots of ways to roll. Yes.
Yeah, exactly.
Okay, good. The other question was on WFS support in Spatial Studio. The question was, which version of Spatial Studio is required to use WFS? And if I'm honest, I don't know. I guess at least 24.1, but I'm not sure.
I'm not 100% sure. I'm not sure. Is David in the session?
I don't think we have David on the call. No.
Okay.
He would know, but then we can get back to you.
Yeah,
Yeah, he would know. Sorry, I don't know off the top of my head, but we can find out.
However, I recommend to use the latest version because it always has the latest and greatest things. So, and it's not hard to switch versions or to update Spatial Studio. So. I just
yes, that is actually true. Even I've done this on a number of occasions, and it did work without problems.
Yeah. Any more questions? If there aren't any questions right now, you have several options to post your questions. There is a spatial channel, or kind of spatial channel on Stack Overflow, where you can post your questions, just tag them accordingly. And there is also the Oracle forum, which you can use. Posts tag there as spatial. We are monitoring as well, so feel free to put your questions over there. We as I said, we monitor it on a regular basis and hopefully get back as soon as possible if there is a question. If not, yeah, you feel also free to reach out to us directly. What else do we have? Check. Yeah, okay, the usual links. And the next Ask Tom session will be at the end of March, and Denise will be your host. Then we already have a speaker on board who is Gautam Pisharam, who's telling a nice story about the Titanic voyage and also the iceberg it collided with. And the second subject is still in the discussion. The question is whether we will be going ahead with the select AI features in relation to spatial feature data and functions, or whether we have a more interesting topic, which could be your topic or something else that we find more interesting, more urgent to present in the next Spatial Office Hour. For today, I thank you for your attendance and your interest, and I wish you a nice day.